Newton believed that gravity existed, sufficient to send us to the moon at any time. Feel trapped in time, questioning if we really understand what it is. Newton's discovery is more than a concept, it's a crucial element that might reveal the mysteries of the universe. Is presenting us the cosmos in this manner, more untamed than we anticipated. How does Brian Cox's innovative concept challenges our assumptions about time and its potential implications for way we see things, which accompany us as we view Brian Cox's recent incredible notion of the time in the enormous. There are mysteries in the universe surrounding us, awaiting resolution, and many things need to deal with gravity and time, two important components of our lives. Suppose there was a planet in which time behaves strangely and might accelerate or decelerate. Additionally, the energy that keeps us on the ground may not be what we think it is. The location of Albert Einstein's relativity theories are useful because they provide Einstein's new perspective on gravity and time. A well-known name provided us with a novel method to examine the cosmos using his theory of relativity. Ideas. His research gave us insight on how time behaves in various contexts, such as when things happen really quickly. It all began early in the 20th century when Einstein disclosed two major concepts such as general and special relativity. In 1905, special relativity altered how it simply states that humans perceive time and space. The same physics laws apply to anyone not speeding regardless of way they're traveling. This concept raises, such as time slowing down or extending down under some circumstances, an explanation of time via a thought experiment. The light clock is changing. Picture yourself is a spacecraft traveling very fast near the velocity of light inside a beam of light bouncing off two mirrors. According to physics, the speed of light never changes, such that the light seems to create an extended angled route for an individual outside the vessel. How long does it take for the light to journey? This route ought to be the same for both individuals on the inside and outside. However, because for the individual outside of it, the journey is longer. It seems like the light takes longer to complete its journey. The time difference is time change, as defined by Einstein, goes more slowly for the individual who is moving, as opposed to the one that is motionless. Thus, time behaves differently depending on how fast you go. Being aware of how things shift as they move. Relativistic or quick impacts aren't merely. Scientists use large machinery, such as pushing the Large Hadron Collider, particles traveling near the speed of light. When things change so quickly that we must consider about time in a unique manner to get accurate measurements and forecasts. Special relativity was shared by Einstein in 1905, and it changed the way we get the cosmos, mostly about motion and time. This notion contradicts what we would. It seems to indicate that physics rules are the same for everyone, regardless of whether they're. Nevertheless, this differs from what we feel every day when we consider whether, when something is moving, we increase its speed, just accelerates. But according to Einstein, the speed of light is the highest speed. In light of this, items that seem to, they occur simultaneously for us, may not seem that way to someone else. Swiftly passing near the speed of light another. Length is the concept derived from this way of thinking. Decreasing in length, which indicates something seems shorter in that way. Movement when seen from a stationary position as well. The well-known equation E equals mc caret superscript 2, demonstrating how mass and energy can transform into each other, which is essential to understanding how small particles behave while they're traveling quickly, and in order to explain things like nuclear responses in real-life situations. Relativity is more than just an idea. Rely on it in technology such as GPS. When GPS satellites provide your gadget with signals, this time act is the reason they're relocating. For them, a little different if we didn't. Consider how our GPS changes with time. Your location information would be completely inaccurate. Thus, we learn about time via special relativity. Is not constant, it depends on how things are shifting, which interferes with the way time and space are often visible to humans. Our typical perspective of the cosmos is rather incorrect time that has been altered by movement. Some fundamental concepts such as light, constant pace, the way energy and mass connect has been shown several times. However, there are more general 1915's relativity delves further into how gravity and the structure of the cosmos connect. It modifies the conventional notion of gravity as only a pulling force. Instead, it states that gravity arrives due to the bending of time and space, or curved is equivalent to claiming that gravity isn't an invisible force. It's simply the way things go. According to Brian General, throughout the cosmos, relativity requires consideration of the four components of the universe: three, space, and once large objects such as planets and stars. And we even manipulate time and space. We sense them at this curve as gravity. Considers space-time to be a large, flexible sheet. When something substantial, such as when you put soil on it, it dips. Anything closer to Earth, like a ball but smaller. This is similar to how it rolls to the dip. Things behave gravitationally, not due to a force, but because to the bending of space-time. The theory of general relativity describes how travel like planets throughout our solar system. It can estimate the trajectories as it round the sun. These planets mimic Earth's production methods. A ring around the sun, distinct from the conventional notion of gravity, just putting everything together, which, unable to describe planets well, the notion is that time and space are twisted like a pliable fabric that complements what we see. A major occurrence demonstrating general the fact that relativity was correct occurred during a 1919 solar eclipse. Sir Arthur, a group led by Eddington, observed how light, as it crossed the sun, stars in the distance bent. According to the hypothesis, the weight of the sun would somewhat bend the starlight. The viewings demonstrated Einstein's correctness by displaying the theoretically sound, just as movement may alter our perception of time. Gravity's effects. Moment when gravity is strong as well, travels more slowly than its weak spot. Thus, if you were close to a hefty object, such as your clock would run more slowly in a black hole, compared to one far from the hefty burden. Black holes are brought up by general relativity. Locations with very high gravity, even light cannot escape a dark border. The event horizon is a hole that, once there is no turning back. When anything goes over this edge, it is pulled into Einstein's black hole forever. The consequences of general relativity are significant for. He began by adding the structure of the cosmos. The cosmic constant is a word that, to his formulas, because he believed when he discovered that the universe didn't move. He said, "The universe is expanding." This is an important error. An expanding universe is essential elements of the Big Bang hypothesis that reveal how the cosmos began. Another significant, the general relativity concept is the bends in gravitational waves are time and space brought on by large objects, traveling quickly as when black holes merge. In 2015, LIGO scientists saw gravitational waves, providing evidence for the hypothesis of Einstein. Over time, scientists conducted tests to verify general relativity, and it has consistently been correct. Seeing the light bending on planets or general detection of gravitational waves. Relativity is still a sound concept. The claim that gravity is a fiction may seem crazy because we experience it every day, but in physics, it's common to wonder about. Consider outdated beliefs that scientists like Brian often questions the conventional wisdom in. Some people have fresh theories about gravity. Is manned or modified Newtonian dynamics, claiming that gravity behaves differently at low speeds, mostly in dark galaxies. Substance as opposed to invisible stuff. Man asserts, when traveling slowly, gravity becomes greater. Dark matter is also discussed in relation to gravity. To explain space-related phenomena, dark energy is introduced. Some claim that these concepts may not be necessary. Perhaps further ideas may clarify what we notice that some scientists disagree with. Investigate new material using Einstein's gravity, such as hypotheses involving unidentified particles or forces capable of altering gravity. It's encouraging to know that fresh concepts in science are not just discarded. Rather, they undergo testing to check to see whether they hold up. Einstein's four-part theory of time, item that prevents time travel from the speed of light, has been examined using concepts such as Stephen Hawking's wormholes. Time travel is made possible via chronology protection, unlikely in physics to go back in time, aiming to determine if these gravity may be explained by new ideas in a manner consistent with what we know, but the known hasn't actually been replaced by concepts. Laws of gravity challenging concepts is essential to the development and improvement of science. Comprehension of the cosmos in gravity. General relativity remains the most popular theory. Most crucial, even with fresh concepts, remains strong and provides explanations for things like general light bending and planets. Relativity endures because it is straightforward and works quite well with Einstein's unique. According to relativity, time may vary depending on. Let's see how this plays out at your pace. Life mostly occurs in space, and space travel is enjoyable yet challenging due of the vastness of space. The quickest pace, therefore, switching between. Even with excellent technology, stars may be challenging. Understand how time passes when you move in. Consider the twin phenomenon in space. One twin remains on the planet while the other takes a quick journey to a distant star when the twin returns, they discover they've aged. They've traveled more slowly than the Earth twin. Time is big for space in the future. Travelers move more slowly on lengthy trips. If astronauts ventured to near, time would move. When time slows very much, stars age. Slower than Earthlings, this might seem like fiction, yet it's true. People being sent to a distant star by humanity. Even if they go quickly, the voyage might take years. Time would seem slower to the astronauts, due to the passage of time, but from Earth, more time would go by before time change occurs. Technology as well as communication on ships must consider time changes in order to work properly. Space traveling has a body. Issues such as being struck alone by distance from Earth and space waves for. We observe time in our everyday lives for a long period. GPS requires the correct signal to change periods from satellites, as these, when satellites are moving, they encounter temporal dilation, so it's crucial to include it into the figures for the readings should be precise without considering concerns how driving might be hampered by time changes. Why do humans only go in one direction at a time? Our lives are governed by time, moving from the past. From now to the future, this one-way journey is part of us, so why should we look at this? How disorganized everything is at entropy, linked to the direction of time, tends to increase. Time is being pushed in one direction as it passes. According to the second rule of thermodynamics, entropy will either increase or remain constant in A. Entropy prefers to increase in closed areas, never falls on its own. The characteristics of time for a more thorough investigation time, as we believe it is closely related to the idea of entropy. Entropy is a basic idea in thermodynamics. The degree of systemic dysfunction, the second law, explains thermodynamics, says that in an entropy in isolated systems tends to grow with time, resulting in a shift from order to chaos. Not only conduct is governed by principles of tangible systems, but moreover offers a structure for comprehending the box, learning in a unidirectional flow of time. To demonstrate this, think about the comparison of a castle made out of sand. Symbolizes a low entropy condition, characterized by a high level of order. and structure over time as a result of natural phenomena like erosion and wind. Eventually, the sandcastle will turn into a beach, pile a higher entropy state. This transformation is a prime example of the natural propensity of systems to change in the direction of more chaos, supporting the idea. Time moves in a single direction from Bach's learning gravity in the future and the structure of spacetime, which is built upon the general relativity hypothesis developed by Einstein. Gravity is more than just a force. It's an expression of the curved shape of spacetime brought on by energy and mass. Large objects such as planets and stars distort the spacetime fabric, and this curvature determines how an item moves. Incorporating light, this groundbreaking. Our comprehension changed as a result of perspective, from considering gravity to be a force that, far from acknowledging it as the spacetime geometry A's outcome. Powerful illustration of this idea is the measurement of gravity, lensing where far-off stars' light bends around large things such as galaxies. This bending is brought on by the galaxy's mass bends the spacetime, which the light passes through, changing. Of course, these occurrences provide concrete proof of the dynamic interaction between the organization of mass energy and black hole singularities in spacetime. Spacetime is one of the most fascinating. General relativity's predictions include areas of spacetime where black holes are. Because gravity is so strong, nothing. Light may even escape from the center of the singularity of a black hole is a point when the spacetime's curvature turns into limitless, and what we currently know, the event horizon, is broken down by physics, denotes the line that nothing may cross, is able to render black holes both mysterious and fascinating topics of research. Current developments in technology for observation, such the Event Horizon Telescope, has made it possible for scientists to take pictures of black hole event horizons that provide factual information that backs up theoretical models. These findings not only confirm features of general relativity, but moreover provide fresh opportunities to investigate the basic characteristics of spacetime and theoretical gravity. Time travel opportunities and limitations. The idea of time travel has been around for a topic of interest and conjecture. In the context of general relativity, some answers to, according to Einstein's field equations, the possible potential for closed time-like routes and curves in spacetime that may circle back on themselves, making it possible to go back in time. But these fixes often entail unusual circumstances, such the existence of negative energy or imaginary wormhole-like structures. Physicist. The timeline was suggested by Stephen Hawking, protective hypothesis indicating that time may be stopped by the rules of physics to prevent paradoxes, go back in time, and discrepancies as time dilation, a relativistic phenomenon in which time, at varying speeds for onlookers in experiments, relative motion is validated and has useful uses. Traveling across time in a way similar to science fiction is still purely hypothetical and unverified. Current events and breaking headlines. The use of math in comprehending mathematics in the cosmos acts as a medium via which the expression of natural laws, and Brian Cox, a physicist, understood, highlights that we learn from our experiences, that the rules of nature really exist, patterns in the behavior of objects, and that the best way to communicate these rules is using the mathematical language. This viewpoint highlights the significant relationship between the physical world and its structures, demonstrating the ability to forecast, using mathematical models to describe natural occurrences. Good reading. The creation of mathematical models, like general tensor calculus, relativity has had a key role in developing hypotheses that precisely explain the gravitational behavior of fields and spacetime curvature. These mathematical instruments allow for physicists to make accurate forecasts and get a better understanding of the mechanisms of the universe's expansion, universe and its consequences. Studies of far-off galaxies show that the cosmos is growing with galaxies that are departing from us at speeds according to their distance and occurrence captured in. According to this expansion, Hubble's law, that there was just one genesis for the cosmos, frequently known as the Big Bang, and has been changing since the cosmic microwave background finding. Radiation offers more proof of the hot, dense beginnings of the universe, providing a glimpse of the early cosmos and bolstering the Big Bang theory model. Recognizing the growth of the cosmos not only provides information about our understanding of cosmic development and the final destiny of the universe. In summary, the interdependence of time, gravity, and the universe. Investigation of gravity and time shows a universe that is far more complex and more interwoven than our daily observations. Indicate that the curvature of spacetime controlling the movements of planets to the mysterious characteristics of black holes. These ideas contradict what we think and encourage more in-depth research as scientific knowledge advances. The interaction between the universe and time. Gravity keeps captivating and growing our understanding of the cosmos. Basic operations observing how things we may perceive times in one method when we go to the mess, like stirring or ice melting,